Hello, welcome to today's class. Today basically we'll be understanding the basic concepts of oceanography. Now, first of all, prior to understanding, first of all, let's understand what is this oceanic crust. Now, remember that oceanic crust is the true basaltic crust. And when I say a continental crust, it means a granitic crust. Oceanic crust is of the first order relief. Now, what exactly is a first order relief? The first order relief is nothing but basically your are the main infrastructure over which other relief exists. Now, in case of, I would say, in case of the Deccan Plateau, I would call the Deccan Plateau itself as the first order relief. Next, we'll move on to the submarine topography. The submarine topography is nothing but the mountains and the ridges that we find over the oceanic crust. These are the second order relief feature. Now, similarly, over the continental crust, the second order relief feature includes your mountain, your plateaus. I hope you got a clarity of it. Now, what is this bathymetry? Bathy means depth and metry means measurement. Bathymetry is basically used to study the submarine topography. How? We use the sonar. Through the sonar, we basically detect what exists on the surface. And the bathymetry basically utilizes your hypsometric curve. What is this hypsometric curve? Prior to understanding anything, just look at this diagram. Within this diagram, you can see this is your continental shelf, which is nothing but the extension of your continental margin. Next, we have the slope, that is nothing but the intermediate between your abyssal plain and the shelf. And last but not the least, the abyssal plain, which is nothing but your true basaltic crust. Now remember this, all these three are your offshore feature, and this, the extended continent, is your onshore feature. So the hypsometric curve takes into account your onshore feature and your offshore feature for studying it. Next, we'll move on to the continental shelves. First of all, the continental, I think that it's VES. Yeah, just a second. I'll just shelves. Yeah, I just made a spelling mistake. Sorry for that. Next. Now, with respect to the continental shelf, remember that they are nothing but the immediate offshore feature. What is this immediate offshore feature? It simply means that it is the continuity of your continental margin, and that this is the submerged part of the continent. Now, with respect to what are the theories of this formation, basic theory that we can basically analyze. Number one is your coastal erosion, followed by fluvial deposits. Simple. And then subsidence. Means your coast is eroded. Who erodes the coast? Basically your marine waves. They erode the coast. This is followed by fluvial deposits. Who deposits this fluvial deposit? None other than your river. And last but not least, subsidence. Next is your fault formation. What is this fault formation? Understand this simply. If this is your continental this margin. Now within this continental margin, what will happen is that there would be a fault would be formed. Hence, as a result of this form, this part will subside and this would be again submerged by the water. Simple. Next is your convergence. Convergence is nothing but this is your, let's again use this black ink. Let this be your granitic, this is your continent, and this is your basaltic crust. What happens that with the convergence of it, if the in case there is a subsidence over here, and this subsidence will lead to the rise in water level. That is the convergence of your continental crust in the and the granitic crust at the margin, and followed by your subsidence. Why does the submergence takes place? Because of the convergence of convective magma current. Convective magma current flows from here, they converge, resulting in your convergence and subsidence. Next is your glacial erosion. What is this glacial erosion? First of all, again let us understand this is your continental margin, and this is your ocean. Now what happened during the glacial period is that there is a rise in the level of the continent, whereas there is a fall in the level of the water, and this part of the continent is eroded none other than by your glacier. And last but not least, during the termination of the glacier, what happened? This gets submerged in the water. Simple. Next is your continental tilting. What is your continental tilting? Continental tilting, again, it simply means that the continent tilts towards the ocean. Now such case has happened. Basically, I would say that your eastern coast of India is tilted. Why did it tilt? It basically tilted when there was a convergence of the Indo-Australian plate with the Eurasian plate. Hence, continental tilting followed by submergence. You basically need to write it like a pointer. Never draw diagrams for this. I have drawn it for explanation. Never ever try and draw a diagram. It will take huge amount of time for these things. Diagram, I'll say what to draw and where to draw. Next. Now what is this continental slope? Continental slope, obviously, as I said, it's an intermediate between your continental shelf and your abyssal plain. I have written it in short form. Next. Now what are the theories of the formation of your continental slope? Again, there is erosional and there is a tectonic theory. Erosional theory says that wave erosion, as we know, and tectonic theory says that there is faulting. Now this continental slope at the bottom or at the piedmont, if this is the continental slope, this is called as the piedmont of the continental slope. What is the piedmont? Piedmont is nothing but your foothill. Piedmont is nothing but your foothill. At this foothill, we can find your continental rise. What is this continental rise? Whatever the debris that comes from the continent gets deposited over here. Again, this continental rise we only find in the passive boundary. What is this passive boundary? If that does not exist over here, a trench. If there is a trench, rarely you are going to find anything over here, because all would be submerged inside this trench. I hope you get that. Next, we have the submarine canyon. What is the submarine canyon actually? The submarine canyon is nothing but your valley that is prevalent within your continental shelf and extends up to your continental slope. Now, what are the theories of formation? Why did this valley within the continental shelf and slope be formed? The first theory is your diastrophic theory. Diastrophic theory says faulting. Look at the diagram, same. This is your continent, this is your ocean, and there is a fault formation. And it is because of this fault that this part got subsided. And this subsidence resulting in the further submergence by the ocean. But again, there is a fault in it. What is the fault? First of all is that the faulting occurs parallel to the coast, but SC means submarine canyon are in transverse direction. Remember that the faulting occurs parallel to the coast. I have not written parallel to the coast, but I should write it down, and I am writing it down. Occurs parallel to the coast, but the submarine canyons are in transverse direction. Next. Now, not all submarine canyons are formed because of faulting. This is second thing. Next. However, this theory has a merit. What? It explains the SC. SC again means your submarine canyon of your Pacific and Mediterranean, but fails to explain the submarine canyon of the Atlantic Ocean, both in the east and west. Next, we have the subaerial erosion. The subaerial erosion is very simple. Most of you must have studied the fluvial cycle of erosion. The fluvial cycle of erosion, what happens that there is a formation of the valley. Valley is formed because of the erosion by the river flowing water. They simply says that after the valley is formed, the valley is submerged into the water. Hence, first erosion, like I have said, by river, and then subsidence. Now again, this is there is a problem with this. What is the problem? Number one, this continental margin. What is the continental margin? Nothing but the meeting point of your ocean and the this last continental shelf. Has to, first of all, as per the W.M. Davis, William Morris Davis, the father of geomorphology, he says that continental margin has to rise to thousands of feet high for erosion to take place, and then it has again to submerge. Now he said that without this it cannot happen, and this is time taking. This is number one. Number two, absence of continuity. Absence of continuity. Just look at this diagram. This is number one and number two. See, supposingly this is your flowing river. The river is flowing, and this is the mouth of the river. Suppose the river starts eroding over here. Obviously, the continental shelf that would be formed, it would have continuity with the river itself. But what happened is that in certain cases, such continuity is not maintained. Means if the river mouth is over here, sorry, yes, that if the river mouth is over here, then we find this at a very greater distance. Means the continental this submarine canyon is occurring at a very great distance. Hence this is not being explained by this theory. Another thing that it fails to explain, it fails to explain that the existence of the submarine canyon below 2000 meter. This theory basically fails to explain such. Next, we have your density current. Now, what is this density current? Density current, just understand simply, the density current is formed at the river mouth due to the temperature and salinity difference of the water. Hence, this density current basically helps in the process of erosion. But again, the problem is that such current persist in the closed water body like lakes, but they are rare in the shallow continental shelf. So something that this particular phenomenon is not that common over here. They were in the shallow continental shelf. Hence, we cannot say that this is the reason. Next, we have the turbidity current. Now remember this, the turbidity current is the most accepted reason of it. What is this turbidity current? Understand this. It says that whenever the water is traveling towards the continental shelf, whenever the water is traveling with it, it is carrying with it turbides. This green color are nothing but turbides, and these turbides basically help in the erosion, and after erosion they are moving backward. Now remember this, the speed of the wave matters. Hence the turbidity current are active during the time of your tsunami or during the time of your volcanic eruption, because it is during this time what happens is that the water moves at a greater speed, whereas in the rest of the time the water speed is very less. Hence it is during the time of the tsunami or due to the volcanic eruption, the turbides present within the that is the turbides which helps in the erosion and the formation of the submarine canyon. Please refer to the notes for more clarity. Next, we have your abyssal plain. Abyssal plain is nothing but your true basaltic crust. Now, what are the features of the abyssal plain? First features we find is your main ridge. What is this main ridge? It is because of the divergence. The plate is moving here, the plate is moving on the opposite sides, resulting in a divergence, hence forming the main ridge. The red basically represents your volcano, or to say the lava eruption, and it is this lava eruption that's leading to this formation of the ridges. This ridges is also included with the auxiliary ridges, which are nothing but touching the main ridge at a 90-degree angle. These auxiliary ridges are also formed because of a volcanic eruption or the magmatic eruption. Next, within this ridge we found sea mount and gyot. Now, at least from the diagram itself, you can make a difference of what is the sea mount and the gyot. Within the sea mount, you see it's conical, and the gyot, you see it's flat top. Next, we also have the submarine trench, and we also have the fracture zone. Now, what is the submarine trench? Basically, what happens is that the plate which subducts beneath, it's because of the subduction of the plate. This is the denser plate, and I'm sorry this having some kind of a problem, just bear with me. Yes, this is your denser plate and this is your lighter plate. Lighter plate is nothing but your granitic plate. Denser plate is nothing but your basaltic plate. It's the basaltic plate that submerges below the granitic plate leads to the formation of your trench. Hence, trench results in your earthquake. Trench. Okay, again we have the same problem over here. I think this app is having certain kind of problem. This trench results in the earthquake. Again, this trench. Again, I'm so sorry. Just trying to make it out. Next, we have the fracture zone. Now, what is this fracture zone? The fracture zone is nothing but again a fault which is formed within the ridge. Now, remember that the fracture zones are devoid of your volcanic eruption, but submarine trenches there are volcanic eruption. Submarine trench you find earthquake as well as volcanic eruption, but the fracture zone you do not find such a thing. Means you find a divergence between the ridges, but absence of volcanic eruption. Thank you. That will be all for today. We'll start with the ocean bottom topography in tomorrow's class. Thank you.